All right, in our last video, we talked about writing numbers in scientific notation. Now we're going to start computing with scientific notation. So we're going to talk about multiplying, dividing, adding, and subtracting numbers that are written in scientific notation. Now we can always just take the numbers out of scientific notation, write them in standard form, perform the operations on them, and then turn them back into scientific notation. But that's a long process. So it's nice to know how to deal with these numbers when they're written in scientific notation and keep them in scientific notation, and it'll save us a lot of time and trouble in the long run. So first we're going to talk about multiplication and division because that's a little bit easier to do. So to do that, to multiply or divide numbers in scientific notation, the first thing we're going to do is multiply or divide the factors. So we're going to take those numbers that are multiplied by the power of 10 and we're going to multiply them together or divide them depending on what we're doing. Then secondly, we're going to use the product or the quotient of powers property that we talked about with the powers of 10. Since they have the same base, they'll both have a base of 10, we can use the product or the quotient powers property. Now remember, the product of powers property says when you multiply, you add the exponents, and the quotient of powers property says when you divide, you subtract the exponent. Real quick review there. And then finally, we need to adjust the answer to be in scientific notation if necessary. Now, sometimes if we multiply or divide, we might end up with a factor that's greater than 1 or greater than 10 or less than 1. So we have to kind of readjust the number to get it back into scientific notation. So how do you adjust numbers in scientific notation if they aren't? If we just need to make a slight adjustment, what do we do with the factors and what do we do with the exponents? Well, there's a real nice rule of thumb that I'm going to use here. If you make the factor larger, meaning you move the decimal to the right, you must make the exponent smaller to kind of compensate for that. If you're making the factor a larger number, you have to make the power of 10 a smaller number. Otherwise, you're making the whole number larger and it's changing the number. And then likewise, if you make the factor smaller, if you're moving the decimal to the left in the factor, you have to make the exponent larger to compensate for that. So they kind of go in opposite direction. Larger factor, smaller exponent. Smaller factor, larger exponent. So let's look at a few examples here of making adjustments. 54.8 times 10 to the 6th power is not in scientific notation because 54.8 is larger than 10. So I would have to make an adjustment here. I would have to move my decimal one place to the left. So that's making the factor smaller. I am making 54.8 into a smaller number, 5.48. So what should I do with the exponent? I made the factor smaller, so I have to make the exponent bigger. So 1 power of 10 bigger since I moved the decimal one place. So this would be 5.48 times 10 to the 7th. Now we are in scientific notation and we're good to go. The next one, 0.098 times 10 to the 10th power. That is not scientific notation because the factor is less than 1. So I need to adjust this 2 places to the right. So I am making the factor actually a larger number. I'm going from a number less than 1 to a number between 1 and 10. So I'm making the factor larger, 9.8. So what do I need to do to the exponent? I made the factor larger, so I need to make the exponent smaller. I moved the decimal 2 places, so I need to make the exponent 2 smaller. So that would be times 10 to the 8th power. So 9.8 times 10 to the 8th power. Now we are back in scientific notation. And then the last one, 3,287 times 10 to the negative 5th power. That is definitely not scientific notation. So I need to adjust my factor so that it is between 1 and 10. I'm going to move it 3 places to the left to make it 3.287. Now it's between 1 and 10, but what's going to happen to the exponent? Again, I made the factor smaller, so I need to make the exponent larger. I moved 3 places to the left, so I need to move increase the exponent 3 bigger, and 3 bigger than negative 5 is actually negative 2. So 3.287 times 10 to the negative 2nd power is scientific notation. So just a quick little lesson here on how to adjust numbers that are not in scientific notation to make them into scientific notation. So now let's get into our operations here. Here I have two numbers that are in scientific notation and I'm multiplying them together. So remember, the first thing I need to do is multiply the factors together. So I'm going to multiply these two numbers together. And when you do that, you get 37.653. And then I'm going to use my product of powers property on the powers of 10. And 10 to the 5th times 10 to the 9th is 10 to the 14th. I add the exponents together. This is not scientific notation, so I'm going to have to adjust. So again, if I want to make that adjustment, I need to make this smaller, 3.7653. So I have to make the exponent bigger, 1 bigger. There is our answer. So we've multiplied these two numbers that were in scientific notation, and we ended up with a number that is still in scientific notation. Next one, again, I'm going to multiply the factors together, 7.53 times 2.93, and you get 22.0629 when you do that. And then I'm going to use the product of powers property, add those exponents together, and you get negative 11. So 22.0629 times 10 to the negative 11th power. And that is not in scientific notation, so I need to make an adjustment. Again, I need to make my factor smaller by a power of 10 to make this 2.20629. So I need to make my exponent 1 bigger. I made the factor smaller, make the exponent bigger, 10 to the negative 10th power, and there is my product. And then this one, I have one number that's in scientific notation and another that is not in scientific notation. So I'm actually going to rewrite these both so that they're in scientific notation. So I've got 1.2 times 10 to the 7th power times 1.5 times 10 to the 3rd power. Now I can use my process here to multiply these. When I multiply 1.2 times 1.5, I get 1.8. And then if I use my product of powers property, 10 to the 7th times 10 to the 3rd is 10 to the 10th. And my factor is already between 1 and 10. I do not need to adjust it, so I am done. So that's multiplying numbers that are in scientific notation. Let's take a look at dividing numbers in scientific notation. Again, I'm going to divide the factors, and then I'm going to use the quotient of powers property on the powers of 10. So if I take 4.62 divided by 1.4, I get 3.3. And then when I use the quotient of powers property, 10 to the 5th divided by 10 to the negative 9th, that'd be 5 minus negative 9, which is like 5 plus 9, which is 14. So I have 3.3 times 10 to the 14th power. My factor is between 1 and 10, so I am done. I do not need to make an adjustment. Next one, I'm going to divide 2.5627 divided by 5.23, and you get 0.49. And then I'm going to use the quotient of powers property on my powers of 10. Negative 9 minus negative 3, that's like negative 9 plus 3, so that's negative 6. And this is not in scientific notation, so again, I need to make an adjustment. I need to make my factor a power of 10 or one place bigger, so it becomes 4.9. That means I need to make my power of 10 smaller. So 1 smaller than negative 6 is negative 7. So that's 4.9 times 10 to the negative 7th power. Now let's look at addition and subtraction with scientific notation. To add or subtract numbers in scientific notations, I have to adjust the numbers so that they have the same power of 10. I cannot add or subtract numbers or in scientific notation unless they have the same power of 10. It's kind of like when you add or subtract numbers or decimals, you have to line up the place values. The place values have to line up, so I have to have the same power of 10 so that my factors are in the right place values. Then I can add or subtract the factors, and I just keep the same power of 10. The power of 10 is not going to change once they become the same. And then again, adjust the answer to be in scientific notation if necessary at the very end. So looking at this example here of 6.28 times 10 to the 4th plus 4.9 times 10 to the 2nd, I cannot add 6.28 and 4.9 together and get 11.18 because the 6 and the 4 are not actually in the same place value. Even though they look like they're in the same place value when they're written in scientific notation, the 6 and the 4 both look like they're in the ones place, but in reality, in standard form, they are not. So that's why we have to make the adjustment to have the same power of 10. So you can see when I write these in standard form, what numbers line up? Well, the 8 and the 4 actually are in the same place value. So this 8 right here and this 4 right here are in the same place value. And we wouldn't be able to tell that unless we have the same power of 10. You see what I'm saying? We cannot add them unless we get the same power of 10. That's basically like lining up the place values. So now if I add these numbers together in standard form, I would get 0, 9, that's 12, 3, 6, 63,290 is the actual real answer. But again, I don't want to have to switch everything to standard form, perform the operations, and then adjust back into scientific notation. So we have to adjust these so that they have the same exponent. Now below, I've got three options. We can adjust to the larger exponent, make everything times 10 to the fourth power. We can adjust to the smaller exponent, make everything times 10 to the second power, or we can meet in the middle, change them both so that they're to the 10 to the third power. Sorry. So let's look at each one of these situations individually, and we'll try to make a decision on which one is best. So I adjust to the larger one. So that means the 6.28 times 10 to the fourth doesn't change at all. And the other one, 4.9 times 10 to the second power, I have to make the power 2 bigger. That means I need to make the factor 2 places smaller. So I move the decimal 2 places to the left to make it 0.049 times 10 to the fourth power. Now if I add these, now I can add them because the place values are essentially lined up. I can add the factors together now, and you get 6.329, and the power of 10 is just going to stay the same, times 10 to the fourth power. And that is the correct answer, because if we write this number in scientific notation, we get 6.329 times 10 to the fourth. So we get the right answer if we do it that way. It's a pretty slick way to do it. We could also adjust to the smaller exponent. So the 4.9 times 10 to the second power stayed the same, but now I made the 6.28 times 10 to the fourth have an exponent of 2. I made the exponent 2 smaller, so I had to make the factor 2 place values bigger. So I moved the place or the decimal 2 places to the right to make it 628. And then again, I lined up the place values here, and I get 632.9 times 10 to the second power. Now this is not in scientific notation, so I do have to make an adjustment. I'm going to have to move my decimal 2 places to the left, which makes it 2 places smaller. So that means I have to make my exponent 2 bigger, and I get 6.329 times 10 to the fourth. I get the right answer, but I had to do an adjustment. And then what about meeting in the middle? Here I changed both of them so that they have a power of 10 that is to the third power. And I made those adjustments, moving the decimal 1 place in both of them. So now when I line them up, I get 63.29 times 10 to the third power. And again, I'm not in scientific notation, so I have to make an adjustment. I'm going to move the decimal 1 place to the left to make it 6.329. And since I moved it 1 place to the left, I have to make my exponent 1 bigger, 6.329 times 10 to the fourth power. Now notice I get the right answer in every single one of these methods. Which one was the least amount of work? Adjusting to the larger, adjusting to the smaller, or meeting somewhere in the middle? Actually, it was adjusting to the larger. Okay, and most of the time that is going to be the easiest, shortest way that you won't have to make an adjustment. So here's our pro tip. Adjust to the larger exponent. Okay, all will work, but adjusting to the larger exponent will typically save you more time. So let's take a look at some addition and subtraction and see if we can perform these operations. Now I'm going to adjust to the larger. That means I'm going to make everything in this first one to the 7th power. So my first number is going to stay the same, 1.7 times 10 to the 7th power. But my other one, I need to move 2 places smaller because I need to make this exponent 2 places bigger, or 10 or 100 times bigger. So this becomes 0.0625 times 10 to the 7th power. And now my place values line up, and then I can just add those factors together, and I get 1.7625 times 10 to the 7th, and I did not need to make an adjustment. That is already in scientific notation, and I'm done. Looking at the subtraction, the 11th power is the largest power, so I'm going to make everything to the 11th power. So I'm going to keep the 2.84 times 10 to the 11th. Here I need to make this an 11, so this needs to become 2 places smaller, so it's 0.054 times 10 to the 11th power, and I'm subtracting these values. So I subtract the factors, and when you subtract these numbers, you get 2.786, and the power of 10 stays the same, times 10 to the 11th power. And that, again, is already in scientific notation. I did not need to make an adjustment. So adjusting to the larger exponent was the better strategy here. So computing with scientific notation, multiplying, dividing, adding, subtracting.